got a nightmare mic situation here. It keeps falling off. We'll just have to hope for the best. If it falls off and I don't notice, will you please shout at me? Okay. The aspect ratio is completely wrong. So, well, as long as you don't mind slightly squished dogs, then we should be fine. Yeah, so I figured I would come here and I would talk a little bit about PureScript, which is my favorite thing in the world right now. And in a broader sense, the state of doing web development in pure functional languages. So I'm going to be talking about not just PureScript, it's fallen off again, but a little bit about Elm and even a little bit about JavaScript. Anybody actually doing JavaScript here? A few. It's very brave of you to admit. Anybody doing JavaScript for fun? Ooh. You're a liar, John Pretty. Yeah, I know the feeling. It used to be really bad. Really, really bad. Back in the olden days when we had to deal with the APIs that were developed for this sort of thing, like the DOM. It's how we do UI development generally for the web nowadays. I always turn to Hieronymus Bosch when looking for illustrations of the DOM. It's oh, this mic. Sorry. The DOM is. It was designed at a time when Java was the new hot shit, and object-oriented programming was sort of just taking off. We'd had C++ for a while, and we were just getting into the fresh excitement of Java, if you can imagine what it was like back then. And we needed APIs for that new scripting language that was starting to form on the web as a platform, JavaScript. And the DOM was the result of this. The DOM is intensely stateful. It's extremely object-oriented. It's very, very slow, still, after 20 years. There's not much to be done about it, sadly. I said I'd turn to Hieronymus Bosch. This one is quite good as well. Quite expressive of how most of us feel about the DOM. And this is how we did web development. To the extent we did client-side web development at all for millions and millions of years, since the mid-90s. And then, fortunately, things started to change a couple of years back. For one thing, React happened. And for another thing, Elm happened. This is a picture of Elm happening. Evan is probably doing some Elm programming on stage, as he usually does. And these two, well, I was about to call them languages, but React is not a language. React is a library for JavaScript, and Elm is a programming language in its own right. And these two introduced some very important ideas. Elm introduced what they call the Elm Architecture, which is essentially, I drew you a diagram of the Elm Architecture right here. It's essentially the idea that is not really new at all from pure functional languages, that you can't avoid side effects, but you try to push them to the edges of your program. And the Elm Architecture is built entirely around that. You have inputs and you have outputs. These are where the side effects happen. And in the middle, there is your pristine, pure functional program. And essentially, the Elm architecture can be simplified down to the update function, which is sort of the heart of your application. Please behave, Mr. Mike. The update function is where all the application logic happens. It takes an action and a state, and the state is the entire state of your application. The core of the Elm architecture is this idea of the single source of truth. So when something happens in your application, the update function gets called with the thing that happened and the current state of your application. And the only job of the update function is to return the new state of the application. There are no side effects at all. It's just from old state to new state, and then it will be the job of other parts of the system to actually represent that as a side effect. That would be, for instance, the view function, which takes your state and, for instance, renders it into an HTML document. And the idea that React introduced is the virtual DOM. And this really changed how we have to deal with the browser as a collection of APIs, because the virtual DOM allows us to write actual HTML as a pure functional program. This is how React's virtual DOM renderer looks. They introduced this thing called JSX, which is a preprocessor of a JavaScript files, which can take these HTML-looking things and turn them into JavaScript for you, so you can actually embed HTML into your JavaScript. This actually was met with such scorn by the JavaScript community that it took React a couple of years to get past this and actually become popular. It took them a long time to see past this scary XML-like syntax and see that there's something brilliant behind that. Essentially, what the virtual DOM does is it allows you to express an HTML document as an immutable data structure. And it allows you to examine the current state of the DOM, create a diff from the old state to the state that you want, represented by a new virtual DOM data structure. And it calculates the minimum amount of work required to get from there to here. So the DOM is still there, the DOM is still stateful, the DOM is still horrifically slow, but you don't deal with the DOM directly, ever. You deal with nice, pure, immutable data structures, and just this one side effect whenever you're ready to make a change in your application. It's very neat. There's been various syntaxes for this. This is another one called hyperscript helpers, which actually just uses JavaScript, so there's no need for a preprocessor step. But common to all of them is the need for a neat syntax, sort of a DSL for writing HTML. And I try to imagine what a virtual DOM renderer would look like. Essentially, you might have a function called diff, which takes the old state of the DOM and the new state of the DOM, represented as virtual DOM nodes, and creates a diff, whatever that looks like. Then you have the patch function, which actually takes a DOM element and the work to be done and actually causes the side effect. And I had to switch to PureScript here because Elm actually doesn't let you deal with side effects at all. It hides them away from you, so I didn't know how to express that other than in PureScript, with this F thing here, which we will get back to. So I want to talk about Elm versus PureScript. I figure it's time for a language fight, yeah? So which is the better language? Opinions? Oh, come on. Haskell, fair enough. PureScript. Any Elm fans? Shout. That's one, I think, to you. So I don't really... Mike's... Oh, there goes the clicker. Mike's completely gone. So I don't really want to get into which one is better. I think that's a pointless discussion. They have different purposes. I'd like to examine those different purposes. Elm actually has a real purpose. Elm is designed to do one particular thing, or rather a couple of things, which is to be a language that is great for writing UI, specifically on the web, but not necessarily. And it's also designed to be a language that is very easy to learn, and it's got a very, very intense focus on good error messages and trying to be as helpful as possible, and good tooling and so on. It's It's designed to be both a learning language and a very clean language for implementing the particular case of user interfaces. Whereas PureScript is sort of, it looks deceptively like Elm. It's a fair bit more complicated. It's a lot closer to Haskell than Elm, really. And it's a real general purpose language. It compiles to JavaScript. It also has a couple of other backends right now, like there's an Erlang backend suddenly, which I'm very excited about. There's a C++ backend, which can actually get you runnable standalone binaries. But most of the focus goes into the JavaScript target. But PureScript is more of a language where we can experiment with these ideas that are essentially Elm is where Evan experiments with these ideas, and PureScript is where the rest of us can play around. Evan turns out to usually be right, though, but at least the rest of us can play as well in PureScript. And I think that these are the focuses of the languages. We should focus on which one is better universally, because there's no such thing. And I wrote you this very cool Raffle. And it turned out I didn't really have anything suitable for it in the talk, so I figured I'd just arbitrarily put in an example of what you have in PureScript which you don't have in Elm. And I guess it's an excuse for some category theory. So, whoa, can anyone guess what this function does? We can't actually see it fully, can we? That's a bit of a problem. Well, I'm going to try and I'm going to resize the window a bit. If I can get to the edges. This is exciting. Okay. Okay, what happened? Ooh, computers. Okay. Now let's see if we can move it. There we go. And then a bit on this side. Okay. If that's the worst that happens today, then I'll be happy. So what does this function do? It's a little bit tricky, I guess, but maybe you can figure it out. Miles, you're tittering. Can you tell us the answer? I'm sorry? It looks like it adds things together. That's a very good guess. You are? It's a function to add two numbers. That is a very good guess. Specifically, add 2 and 2. Shall we see if it works? That's 4. I don't know. Is that right? Good. So we have a function that adds two numbers. That's great. This isn't anything that Elm can't do. The type signature says from integer to integer to integer, which means it takes two integer arguments, it returns an integer. So let's just test if we're in JavaScript. This is going to be 0.3, right? Actually, oh, this is a type error. Because these aren't integers. So PureScript has a number type, which we could just change this to, which would be horrifically annoying. Or we might actually have like an add float function, which takes numbers. And this is what you're stuck with in Elm. This is for a good reason, mind you. It certainly gets you great error messages, but it's not very flexible. This is like generic programming 101. What we can do in PureScript is we can say, let's introduce a type variable n. You can also do this in Elm. But of course, we have to declare it. Of course, we don't know anything about n, except that it's going to be the same type for all three arguments. We don't know that n actually has an addition function. This is where type classes come in. So what's a great type class for this? What do we call a thing where there is an addition function, so we can add two things together and get a third thing? A semigroup?
What if I want to add a string and a number?
If you want to add a string and a number, you'll have to use JavaScript. Yeah, so a semigroup has a concatenation operation. It's a binary associative operation. It's not quite what I'm looking for. Actually, I'm going to give you a hint. We're looking for addition and multiplication in this case. In category theory, we call that a ring. Can we be slightly less concrete about that? Semi-ring. It's a great audience. You know your category theory. So we specify the constraint that n has to be a semi-ring, which gives us, thanks to the prelude, plus and multiplied by. So now this should actually compile. I thought it would. We have an issue here. Computers. I'm just going to reload this. Oh, is that? Yeah, that wasn't my problem, though. It was the size of the semi-ringen. That was the error that I couldn't see. Good spot. Okay. Now it's going to be 0.3, yeah? Close enough. It works. At least we have type classes. And speaking of type classes, there's another interesting difference between Elm and PureScript. Elm is, I say it's strictly pure, but what I mean is that your code doesn't really deal with side effects. The side effects are there at the periphery, but Elm sort of hides them away from you in the machinery of the Elm runtime. So everything you write is pure. And you might do things like return certain values that mean there should be side effects, but they just sort of go off into the system, and at some point the inputs come back and call some of your pure functions. Whereas in PureScript, you deal with your own side effects. There is no runtime. Literally, there is a very small prelude, and most of it will get optimized away if you don't use it. Whereas Elm has a fairly sizable payload for doing its magic. So I said at some point, PureScript is a mostly pure language. Of course, all the code that you write is technically pure, but there's this mechanism that you actually see in PureScript, which you don't see in Elm. Do you know the name for it? I showed you the thing earlier, the F thing. That is a thing called a monad, which were discovered, of course, by Professor Woodler here. I like to say. I think is blushing or is mad. This is another thing about Elm. You never hear the word monad. You never hear any talk of category theory. To be fair, it doesn't have type classes, so you can't really express them very well. They are there. You don't see them. In PureScript, you're left to deal with this yourself. For better or for worse. I happen to think it's better, but that's, I think, a personal preference. So what about JavaScript? Where did my clicker go? There. I just wanted to say that if you're actually stuck doing JavaScript at work, all hope is not lost. You can still be a pure functional programmer. You have things like React and Redux. Redux is an implementation of the Elm architecture for JavaScript, which it's not tied to React, but it's sort of React-centric, and they go extremely well together. They really help you write clean and pure code, but of course you have to be disciplined about it in JavaScript because there's no compiler keeping you from writing impure code. You have type systems, which help a lot. You have Flow, you have TypeScript. And this is a cool thing I discovered recently, ESLint plugin FP, which disallows things like mutating data structures and reassigning variables and things that have side effects. It's a very cool little toy. But I'd like to focus on PureScript today, or at least the time I have left, which is about half my talk. That's about right. I want to actually get to do some programming for you as well, not just the add function. That wasn't very exciting. But I've been trying to focus on growing the PureScript ecosystem towards being able to write pure functional UIs easily, cleanly in PureScript. Elm comes with all this sort of preloaded. Elm has a framework laid down for you and a very specific way of using it that the Elm implementers have sort of decided are the right way for you. And as I said, they're usually right about this. As a consequence, I happen to have stolen quite a bit from Elm and put it in PureScript. For one thing, we need a library for streaming state. And Elm's signal library, which is now gone from Elm, actually, was ported about 2-3 years ago. Did PureScript exist 3 years ago? I think it's been almost 3 years now. Anyway, so I wrote a signal library at some point, which seems to have been popular enough that we haven't really seen too many other alternatives. But certain frameworks have implemented their own versions. I mean, the point of this is to have as many options as possible, so I think that's great. Virtual DOM implementations. Basically, we've just been wrapping React, or sometimes JavaScript's virtual DOM library. It's called virtual DOM. Just recently, I felt like there was a need for implementing this in PureScript directly, because frankly, the package management story is not great if you're dealing with JavaScript packages as well as PureScript packages. You're sort of stuck with two package managers which don't talk to each other, and you have to basically make sure that your JavaScript dependencies are installed on your own. You have to know which JavaScript dependencies are required by which PureScript dependencies, and so on. So I've been sort of trying to move us towards writing everything in PureScript because that makes package management easier, quite simply. So I wrote a virtual DOM library at some point, a month or two ago, and then immediately afterwards somebody else wrote another one, which looked quite a bit better. And hopefully there's going to be 2 or 3 more, and we can pick the best one out of that. It's growing at least. And there's a need for a clean DOM DSL, like JSX or HyperScript or anything like that. A couple of years ago, I stole Blaze from Haskell and turned it into a PureScript library called Smolder. And a couple of React bindings have been experimenting with DSLs that look sort of like Elm's, which is very simple. It's just a function which takes a couple of lists, one list for attributes and one list for children, which is perhaps the cleaner one. Mine has monads in the backend, so it's obviously the cooler one, but I haven't decided which one I prefer yet, to be honest. And I figured once we have those, magic will happen, and we will have like a killer framework for writing UIs. But actually, we have several frameworks. We got Halogen, which is trying to be fancy. There's a lot of category theory in there. There was talk of profunctors and whatnot. Halogen is actually being used in production at Slam Data, which is the only PureScript-based development shop that I know about. Thermite is Phil Freeman's React bindings with some extras. Phil Freeman is the original author of PureScript. And Pux is perhaps the most popular one right now, which is kind of a port of the Elm Architecture to PureScript. But what these have in common is that they are not composable. They have basically implemented all of these libraries inside themselves. The difference is Pux is using my signal library, but all of them have their own implementations of DOM DSLs tied to their own JavaScript bindings. And I wish we could break them up a little bit to make it all a bit composable. So you can pick and choose whichever you prefer. Enough talk. Let me try and show you what I'm talking about. So, is that actually readable to you? Yeah, there's not much I can do about it, unfortunately. It's literally, the screen is just mangling all of this. So I'm going to have to try and make two. Let's try and compile this program. So this is a PureScript program. It's a module. It's got a lot of imports. It's got a main function. And right here we got sort of the ugly innards of PureScript's DOM bindings. You shouldn't even look at this. It's just disgusting. But essentially what it does, with a lot of maybes and back and forth casting things and whatnot, it gets the HTML document. Out of that, it gets an element with ID of target. And then if we actually manage to find that, we call the function called view with that target as an argument. So if I compile this, obviously, that's even more unreadable, but I can actually do something about that. Is that readable? Apart from being Comic Sans. So it's saying I need a function called view. And I actually just wanted to show you how to do the DOM DSL in PureScript. So I'm going to, or rather, I want to show you the virtual DOM in PureScript, sorry. So I'm going to write this view function. The view function takes the target element, which we already found in main. And we have a do block. And the job of the view function is basically to call the patch function or the virtual DOM. And on the target element. And the previous value, let's just make that nothing because we don't have any previous value. And we render our little DOM thing. So now I need to write the DOM thing. So just a very simple element. This is not even my DSL. This is just the innards of the virtual DOM thing. So I have a function called age, which makes a virtual DOM node, which should be a header element with no properties, and one child, which is a text element. Hello, Joe. And now let's see if that compiles. Whoop! We got an H element, an H1. It's terribly exciting. We can even do the entire set. Hello, Mike. Hello, Robert. Anybody else wants to shout out? Give me a name. Who? Everyone. Programmers always generalizing. Okay. So we've done some DOM rendering. But we've done it in a pure language with pure data structures. I think that's a slight improvement on jQuery. So let's see. Let's take that a step further. Let's try with a DSL. So here I've already pre-written the view function, not to bore you too much. So I'm just going to write my DOM again. So this is the Smolder DSL that I did a while ago. That is, if you've seen Blaze on the Haskell site, it's pretty much exactly the same thing. It has a number of functions which map to DOM elements. So I can go H1. No, sorry, I'm going to do a div first to show you how you can nest them. Because this actually, because these are monadic values, I can use do notation to make children. So div do means a div with these children inside the do block. So that will be an h1. And the h1 takes an argument, which could be a do, or it can be just one child. And the text element is one child. Hello, Joe. Woohoo! We can even add parameters to this, like the style attributes. They're called actually. Sorry, the style attribute. So we can make it blue and pink. Ooh, and red. What's your favorite color? Magenta, obviously. Ooh, it's fantastic. At least it's a slight improvement on the ugly syntax that I was using earlier. So that's great. And how much time we got? About 10 minutes. Let's actually write an application. I figured we'd go for something extremely complicated, like, say, an application that has two buttons, increment number and decrement number. And we have a number that starts at 0. And you can imagine what the buttons do. Do you think we'll be able to do that? It's going to be a bit of a challenge, though. So, I got some boilerplate here. I've essentially implemented the Elm architecture for you right here. So I got the main function, which is doing basically the same stuff, except it's now using my signal library. And we have an app function, which deals with transforming state and actions into views. So this is all boilerplate. What we're interested in is the render function and the update function. And the update function is the logic of the application. The render function is where we turn the state into HTML. But first of all, we need to define the state. So given my specification of the application, what would our state look like? A number. Let's be specific. Let's be integer. So this, of course, isn't really demonstrating how you can compose states together, because this is all we need. That will do. And we'll need an initial state, which is of type state. Oh, I don't know. 0? The agony of choice. Okay. So that takes care of our state. So far, we need actions as well. What are the actions that could happen in this application? Increment and decrement. And we also need, because signal always needs to have a value, we also need a no operation action. So let's do data. Action is either no op, or it's pred or suck. So predecessor and successor. Because I figured we'd render natural numbers. So you can't go below 0. Though I'm not sure I actually deal with that in this application. That will be an interesting exercise to see what happens. Anyway, so the update function is fairly straightforward. The update function takes an action and a state, and we case on the action. So if there's a no op, then we just return the state again, unchanged. If we want the predecessor, then we go, oh, I did deal with that, max of state minus 1 and 0. So we take the state, we decrement it, and we make sure it doesn't go below 0. And the successor is just state plus 1. It goes to plus infinity. If we have enough time today, we might get to plus infinity. I'm going to start clicking buttons later. Okay, and we need the render function. How are we doing so far, by the way? The type declaration for render should be followed by its definition. Okay. We can do that. So that takes an action channel. This is for pushing events back into the system, and it takes the current state to render. And I'll use the DSL again, so... Oh no, I won't actually. Yeah, this is the thing that I've been struggling with, joining up my DSL and my virtual DOM renderer, because there are some rather nasty issues with type inference in the PureScript compiler, so I've got it working, but I have to have extremely explicit type signatures on like every value I write when I want to introduce callbacks, which is a bit annoying, or event handlers, not callbacks. So I'm going to use the nasty-looking virtual DOM syntax. So I'm going to create a div which has no attributes and has these children. First, an h1 with a property called style. Actually, let's wait. Let's leave that for the Z. And a text node as a child, which prints the number. Number and concatenation, and a function we are going to write called nat of the state. And then we want some buttons. That's our button with no props and text pred. And then we need to add an event handler. I'm going to run out of space. Let's do this. On an onClick handler, which takes a function with an argument we don't care about, which just sends the pred action to our actions stream. That should do it. And I'm just going to copy this one, not to bore you too much. And I'm just going to change pred to suck. And I think that should work. Unknown value nat. I need to implement this nat function, which turns our integer into a string, but of course I'm going to pretty print it, so it's going to be a little bit easier to read than all these Arabic numbers. So nat of 0 is Z, and nat of n is successor of nat of n minus 1. Oh, unknown value action. Where is that? Line 39. I wish I put line numbers on this. Yeah, I figured. Oh, actions. Oh, thank you. There we go. That's the application. Number Z. That was a large one. Shall we make it H4, H3 maybe, so we can read it? Okay. Woohoo! We are incrementing and decrementing numbers. That was worthy of applause, I thought. Okay. So I got a couple of minutes left, so I'm going to add dessert for you. I was actually going to, on the header element, I was going to add a style property. This is like deep magic. The style property, I'm going to make it so that when the number increments, we're going to change the color of the header element. Are you ready for this? So that will be color is RGB, and we're going to increment the red element. So just make some space. Show, it's got to be min state multiplied by 8 and 256. So we don't go over. Are we balanced? Yes, we are. And we just need to add the green and blue elements. That should do it, I think. Ooh. Expecting no indentation at end of input. What should I do now? Any Haskell experts see my indentation error? I hate it when those happen. Wait, there's something funny here. The style. Do I need to increment this more? Yeah, probably. No? Okay, what the heck? I'm just gonna... Oh, stop being difficult. Ah, if only I had my Emacs. Okay, that's interesting. So that changed nothing. Which one is it? 37.3. There is a what?
Parenthesis at the end of the line.
At the end of this line?
After the column.
After the collar?
Yeah. Below. At the end of the line.
At the end of this line?
Parenthesis goes before the bracket.
Oh, look at that. That's really weird. Okay, can we untangle this? These are balanced. Oh. That's it. Thank you. So if I had a decent editor, this would have highlighted where the problem was. Of course, I didn't have time to write you a decent editor. But okay, so let's try this. Watch the color of the number. Oh. It's turning redder. It's turning really red now. I think that's probably as red as it's going to get. Oh, the excitement. All right, actually, I believe we just ran out of time. So I'm going to call it. Right. There. I'm going to call it. That was my cheat slide in case I screwed everything up. That's the entire application. Still there. And, oh, come on, computers. That was my final slide. Thank you so much for bearing with me.